This one is basically going to be using PRTG, which is a monitoring and NMS tool, which we're going to use to monitor and graph out our bandwidth usage of our queues. So there's a lot to take in there. Basically, we're going to use this application here, which is has a free version, which we can run on a Windows machine, which we'll be running on the machine I'm on right now. And we're going to use the unique OIDs, which is the effectively the SNMP unique ID for the particular type of traffic we want to then poll, and it's going to do that every minute or 30 seconds or whatever we set, and then it will graph that gradually, so as the bandwidth increases. But I think it's easier if I just get straight into it rather than trying to explain too much now, because it become a bit clearer. Just a heads up before we get going, what I'm going to show you right now, I've also got this which I'll put a link in the description, is the how-to basically on the website. So every video I do, I try and add a step-by-step guide as well, just because sometimes it's easier to follow, or if there's one particular step you missed, you can easily refer back to here, and then he links to other useful stuff as well I've included there. There's also a link here to download the PRTG, but we're not going to go too much into the actual deployment of PRTG. I'm going to assume that you've got away and done that yourself. Click on the link, it's very easy, it's just an installation file, and then it runs on your machine. You can access it via, as I'm going to access it via my local, my machine, sorry. And then when you come to set up, there's a local probe which exists on the as part of the actual server, and then it will do like a discovery, but we don't want to do that because it tends to pick up a lots of stuff we don't particularly want to monitor. So the way that this works as well is we get a 30-day free license of the full PRTG suite, but then when that expires, what it does is it just reverts you back to limiting you to 100 sensors. Now, a sensor isn't just necessarily a device. A sensor is, so you've got a sensor, so you've got a router and you're monitoring 5 ports. That's 5 sensors. But then that's also, you could be monitoring the ports for, the interfaces for ping, SNMP. Each one of those is a sensor, so you can quite quickly use those up. But if it's a small network, if you're doing some troubleshooting, this is ideal. You stick this on a machine that's inside the network. You can, add in all the devices you're having problems with or you want to monitor, and then away it goes. So what this is going to do is, I'm using queues here on this MikroTik. Again, there's links to other videos I've made about the queuing and the bandwidth shaping. Basically, the queue is what's going to use to limit my traffic to 10 meg each way. I won't go into that because that's covered in other videos. But there's a Mangle rule behind the scenes which is matching my local traffic of this machine, and I'm limiting it to 10 meg each way. And then what I'm going to do is, once I've got it capturing that data, I will generate some traffic, and then we can see the graph and as it goes up and down. So the first thing we're going to do is we're going to enable SNMP. Now, if you're not familiar, SNMP is literally stands for Simple Network Monitoring Protocol, and it's a way that these NMS, these network monitoring systems, can go in and poll our devices for information. So it can be all sorts of information. There's heaps of stuff out there. There's libraries called MIBs, which each vendor has, and they have these unique OIDs, as I'll show you in a minute, which will identify the objects that we're polling. That will then periodically go and grab this information. So it can do things like pings. So it can do it can check DNS. It can do HTTPS, HTTP web gets. It can do SSL cert verifications. There's heaps of things like Cisco. There's lots of actual vendors have their own suite in here, and you can, like I said, you can add other libraries into this. But this is basically going to monitor these queues in particular. Now, we could just monitor our interface. So we could just monitor our bridge, which I've got the LAN bridge on here. We could monitor that, but I'm going for the scenario that you've got this is only monitoring, say, a single IP or a single group of IPs, or you've got this is say a shared, so you're a small ISP and you're providing a CDNAT interface to all your clients, so they're on a shared subnet, and then WAN IP is actually a local one. It's all in the same shared subnet. You can't then, you could have individual rules, mangle rules matching their IP addresses that you've assigned to them. So then you can see, and then you could do that to rate limit their traffic, as well as then graph their traffic for, give that to the client to say this is how much you've used. Perhaps you need to increase your bandwidth. There's all sorts of applications for this. I could spend hours talking about different things I've used it for in the past, but really this is just about showing you how it works, and hopefully it becomes clear of the uses afterwards. So we go ahead and enable this. I would always use version 3 because it's the most secure. People that know would have used version 2. You have this trap community where it's basically just a word, a string, which is used to identify, basically allow that device to grab that traffic from your machine. But if we go to communities here and we add a new one, we're going to actually give it the username and the passwords here. We're going to give it a bit more added security. So where this name is, it's not actually the community name, it's going to be the username for this user. Address will allow it from everywhere. Security, we're going to authorized, and then read access. Okay, we're going to go for SHA-1 and AES, and then we're just going to choose. Normally you would choose a secure password, but for simplicity I'm just going to use those. And again, need something longer, something more complex and different from each other. Okay, that. We can close that window, and we don't need to worry about changing that here because we're not actually using that as a trap community. Okay, and then the rest you can fill out the contact info, and that's basically something else that can be polled from the device, but we don't need to worry about that for this example. So now what we're also going to do is we're going to head over to the firewall. Now I've actually got this running on the machine that is on the same LAN, which I've also, if you see my video on sort of best practice for firewalls, I do it by dropping all input traffic, so that's anything destined for the device, which is what the SNMP is going to be doing because it's polling that device itself. And then above that I have an allow rule, and then it's based on a source address list, which is basically anything that's under this allowed hosts, of which this is my LAN and that's allowed. So the other option you could do is add a input chain, and you could specify the protocol, which is for SNMP as UDP and then 161. You can also give it the source IP address of the machine which is doing the polling, which in this case is this, or you could just do it, allow everything from that IP. So there's various ways, but obviously the more granular you go, the more secure it is, and the less likely you are to open the door to something you don't want. Just obviously make sure that is put above the drop rule, and this drop rule I've added as well. This doesn't come by default. Okay, but again that's all covered in another video. So now we can test this SNMP. So if we jump onto our PRTG, we're going to add, we right click on that, and we're going to add a device to our local probe, and we'll just call this MT test. That's what it is. Now the IP I'm going to use is which is the default gateway for this machine I'm on, is also the IP of the LAN bridge. I always like to make it identify. We now have a MikroTik icon there. You've got all the other ones in here, and then you can set this higher up. So you could set, so it's inheriting this from the local probe. We can put these settings on the local probe, which is the step up, if you like, because you can install probes. So you had this server outside of your network, you can then install these probes inside networks or machines and allow that communication will talk back to your server. You don't actually have to install your server directly on the local network. You can have that hosted anywhere in the cloud or something, but on the server it has a local probe, and that's what we're assigning our devices to. And then you could set the SNMP details in there, but we're going to assume that we're doing it for just this one device. So we untick that, and it allows us to set the SNMP details here. So go SHA to match what we put before. So that SNMP-user is that name or community name as it was in the MikroTik, but it's not actually. And we put that super secure password in, and then the encryption type is AES, and again the encryption key is that encryption password, and then yeah, everything else we can leave default. Okay, and then that should appear. Okay, now we add a sensor. Now we're going to test it by adding just an SNMP, where is it? Traffic. Ooh. SNMP. Oh, I don't know why custom sensors is ticked. SNMP traffic, there we go. Now what this is doing, if you don't get to this stage, then it means that your SNMP details aren't working. So you may have typed the password incorrectly, you may have the wrong encryption or authentication type. It's just worth just double checking that. You wouldn't get to it, would that sort of that bar that went across that would stop and eventually time out and say we can't talk to your device. So as you can see, these are all the interfaces that are on my MikroTik. There's our LAN bridge. That's our connection to our internet, and that's our connection to this machine I'm on now. So we could just tick so we could obviously, if we had all our machines plugged across, or if this was a switch, we can just monitor the individual ports, which is fine, but we don't always know where everything's plugged in. It could be plugged into an unmanaged switch, it could be Wi-Fi. This is, by doing a queue, it captures everything. So we'll just do that for now, just to confirm we're good. And then what happens is this will just take a while to poll. But in the meantime, let's jump back on our MikroTik and let's set it up for our main purpose, which is to do the queues. The reason I'm showing you this is because these queues don't show up on that SNMP traffic. So they're separate. They're not seen as an interface. So this is a way to get around that. So we go to open a terminal, and then we just go to queue, and then we're using queue tree. Go to that menu, just tree, and then we go print, and then that gives us obviously what we can see here, all our settings, and there's our names. 0 is download and 1 is upload. And we just do that same command, but after we put OID for the object identifier, and here we go. As you can see, again, it's the same 0 and 1. But now we have all these OIDs for the different. So we could monitor packets. We could monitor the queues, the name. We could pull the name directly using this string, this ID here. But we want the bytes. So let's go ahead and copy the first one, which is going to be download. Head back over here. Still nothing coming out here, but it will be shortly. Oh, there we go. So as you can see, this live graph here will eventually start to populate with stuff, and it monitors the upload and download. But let's go ahead and add our bespoke one. So we go back to RMT test. We're going to add a new sensor, and this time we're going to type SNMP custom advanced. So we want the advanced one. Okay, we're going to call this our queue traffic. Now we could have this could be our, whatever our queue is doing, different types of queues, different names and identifiable, but because we're going to do download and upload in one, we don't need to call it like queue traffic download and queue traffic upload. So we get this one, the first one wasn't it, was download. In here we put that OID. We got delta because it's going to be a counter, periodic counter of the bytes. We select bytes bandwidth, and then that will determine whether we're using megabits, gigabits, and then the next one is the channel 2. We enable that, and then this is going to be our upload. Doesn't matter which way around you do this. And then we pick bytes again. You just need to make sure you get that leading 0. Paste, and then delta again bandwidth, and there we go. So we're not going to capture anything else. We could do, but we're not going to in this one because we just literally want upload download. All the rest can be, well, the interval is there, it's set, but we'll inherit that from, it's every 60 seconds, every minute. We can leave that as standard, and that's it pretty much. Create. Okay. So we click right here. Again, this is going to take some time to populate. But in the meantime, what I'm going to do is, actually, I'll pause this now and I'll restart it once it's enabled. Okay, there we go. So that's now, if we click on our live graph, we can see we obviously nothing at the moment. As this machine's in the background talking to the internet, that will, after a minute, will just show a few megabits going across. We can untick downtime. Downtime comes in by default. We don't worry about downtime. There we go. So we've got a very small amount of traffic being grabbed now. So what we're going to do is now I'm going to max out these queues, or at least the download queue. So what I'm going to do is going to go to Ubuntu download. I'll just download the large files, just download the Ubuntu ISO. Okay, download. Wait for that to start. There you go. So we're now downloading. Just jump back on my MikroTik. Queues are going up. There we go. So we're now maxing that out. So we go back to our PRTG. If we can refresh it, if that does anything. There we go. It's gone up a bit. Here we are. So it's now up to. Again, I'm just going to pause this and let this sit for a few minutes and just gather a bit of traffic, and then we'll take a look. Okay, there we go. So that's been running for a few minutes now. Obviously it spiked when I first started that download off, and then it settled down to its limit of, so you can see it's still being rate limited to 10 meg. These are just simple default small queues, so there's nothing fancy. There's no I'm not doing any prioritization or anything like that, but it's just really just to show you. I could just turn that off, and then that will shoot up. Okay, now that I've turned that off, the obviously the traffic's now dropped down to 0 because there's nothing to monitor, because the queue's not grabbing any traffic. So if I compare that to that land bridge one I did, as you can see, that traffic's obviously shot back up higher now. There you go, re-enable that. Okay, so hopefully you can see some benefit to this. Hopefully it was clear enough. Again, follow that link in the description. It should be give you all the information you need, but if not, please comment below. I can go into more detail, or if you've got any other use cases you think might work, you could monitor all sorts of things on the MikroTik. Everything on there pretty much will have this unique ID, which you can find, and then you can monitor that instead. So yeah, any other thoughts, please let me know. Otherwise, thanks for watching, and please like, subscribe, and I'll see you on the next one. Thanks.